Today let's talk about radical expressions. So up here we have a pretty simple little rule here, and it says if I have the nth root of AB, that I can actually split that up. So if it's A times B like that, I can split it up to the nth root of A times the nth root of B. And the same rule applies for fractions. So if I have the nth root of A divided by B, I can split that up into two fractions as well. And hopefully that seems to make some sense. Those rules come directly from our exponent rules. Remember, we had exponent rules that said if I had a b to the nth, I could do, or I could rewrite it so it says a to the n, b to the n. Essentially the same thing, because an exponent, or pardon me, a radical is essentially an exponent, it's a fractional exponent. And the same thing here. If I had a over b to the n, that would be the same thing as a over n divided by b to the n. Okay, so let's take those ideas and let's see if we can simplify some radical expressions. So as I take a look at this one right here, I notice that I have a fraction. So using the second rule that we had up here, this right here, what this tells me is I can actually do this. I can split it up. Square root of 4 is 2, easy enough. The square root of x to the fourth is x squared, and can't do anything with the 5. And there you go. Just like that. Okay, so let's take a look at the second one. It says 20 root 8 divided by 3 root 2. There's a couple different things you can do with this. I guess one route that I would just take maybe would be to simplify root 8. So root 8, now radical 8 is the same thing as 4 times 2, so the square root of 4 is 2. Okay, so as I look at this, I notice I can cancel my root 2's. Why? Because when it says 2 root 2, it means 2 times root 2 right there. Same thing here. So I can cancel those out, and I would just get 40 over 3. Okay. Now again, as I said before, that's not the only way you can solve that one, but that's a pretty simple way. Now what about this next one, number 3? Number 3, there's not a whole lot we can do with it right away. But what we're going to have to do is we're going to have to do something called rationalize the denominator. Okay, rationalize the denominator. Oh, I'm going to run out of room. Okay. And what that means is you're going to try to make the denominator a rational number. So the way you do that is you're going to take your radical, and I'm going to multiply top and bottom by that radical. So I'm going to multiply by root 7. So up on top, I get 5 root 7. And the bottom, I get 2 root 7 times root 7 is root 49. But I know what the square root of 49 is. The square root of 49 is 7, so it's 5 root 7 times 2 times 7, which is 5 radical 7 over 14. And there's nothing else I can reduce, so I'm done. So I've turned that denominator into a rational number. Thus the name rationalize the denominator. Well, let's take a look at this fourth one right here. So again, you notice we have a radical on the bottom. Having radicals on the bottom are something that we are not going to accept as simplified. So I need to get rid of that radical. So how do I do it? Well, I'm going to rationalize it again. So in other words, I'm going to multiply top and bottom by the square root of x minus 2. So up on top, I get 6 root x minus 2. On the bottom, I get the square root of x minus 2 squared. And so what do I get here? Well, the square root of x minus 2 squared is x minus 2. Now we're going to go backwards here because I'm running out of room. So I get 6 root x minus 2 over. Okay, now down here, like I said, the square root of the x minus 2 quantity squared is x minus 2. Now, this is an even, odd rule. So in other words, this is an even even. The exponent of this is odd, so it should be this, absolute value. Okay, so sometimes, though, things get a little more complicated, like this one. You notice that the bottom is not a square root. It's actually a cube root. So what do you need to do? Well, up here, when we are doing rationalizing the denominator, we multiplied by root 7. Okay, why did we do that? Because 7 times 7, or 7 squared, is 49, and you could square root that. So if it is a cube root, we don't just need to multiply by root 5, because you would end up getting root 5 squared, and you still don't know what the cube root of 5 squared is. So for instance, let me write that down here. So here's the situation you want to avoid. Before, we just multiplied by root 5. Let's just talk about the root 5. We'll ignore the x squared for now. That doesn't help us this time, because now I would get this. And do you know what the cube root of 25 is? No, you don't. So you don't multiply by 5, but in this case, we're going to actually multiply by 5 squared. Okay, the reason for that is because we're looking for a cube root. So we need 3 of these 5s. There's 1 here, 2, 3 here. So now you can find the cube root. So as I look at this problem here, I'm going to multiply by the cube root of 5 squared on top and bottom. Now what about my variable? It's cube root of x squared. I need this to be an x to the third, so that means I'm going to multiply by x here. So up on top I get 3 cube root 25x over cube root 5 times 5 squared. 5 squared is 25 times that is 125 x to the third. Do I know what the cube root of 125 x to the third is? I sure do. So on top, it's still 3 cube root 25x. On the bottom, the cube root of 125 is 5. Cube root of x to the third is x. And there you go. I'm done. Just like that. So the key here is the fact that it said cube root. So I needed to create 3 of these. He already had 1, so I multiplied by 2 more. Here you had 2 of them, so I multiplied by 1 more. Okay, so let's take that idea and let's apply it to the next one. Well, if this time it says the 4th root of something, so that means I'm going to need 4 of these things. So what I would do is I would multiply top and bottom by, you have 1, 2 here, you need 3 more, so 2 to the third. You have 1x, so I'd multiply by x to the third. You have 2y, so I'll multiply by y squared. I'll do that top and bottom. Okay, so what I'm going to get is 9. 4th root of 2 to the third is 8. X to the third, y squared. Over the 4th root of, you get 2 to the 4th, x to the 4th, y to the 4th. So I can simplify that. Whoops, sorry. A little off here. So I can simplify that. The top is going to stay the same. And the bottom, the 4th root of 2 to the 4th is 2. The 4th root of x to the 4th is x. The 4th root of y to the 4th is y. Now technically here you have an even, odd rule, where this is even, this is odd, so that should be absolute value. Same thing here, even, odd. So this all should be absolute value, like that. Okay, that's quite a bit. So let's take a little bit of a break from simplifying radicals here. Let's just talk about simplifying when you're dealing with adding and subtracting. Now the deal with adding and subtracting is you can only add or subtract radicals that have the same radicand. So in other words, these numbers inside the radicals have to be the same. And if they're not the same, then you can't simplify them. But sometimes they're a little sneaky, like this one right here. I see we have 3 root 27. Well, I can simplify that. Rewrite this, and I can simplify root 12. So square root of 9 is 3. So I get 9 root 3 minus 7 root 3. Square root of 4 is 2. So you notice that all the radicands are the same, so I can actually simplify that. 9 minus 7 is 2. 2 minus 2 is 0, and I get 0 root 3. Well, 0 root 3, it means 0 times root 3, so the actual answer is 0. Now, one of the last things we're going to talk about with simplifying radicals is if you multiply. Multiplying is easy too. Multiply, you're going to just simply multiply the numbers on the outside, and then you multiply the numbers on the inside. So what I mean by that is if we're going to multiply these, you're going to distribute. So I'm going to multiply this. So I would leave the 2, and then root 6 times root 3 is root 18. Again, I would leave the 6, and then root 6 times root 5 is root 30. Multiply here. 2, root 3 times root 3 is root 9. And then multiply here. Root 3 times root 5 is root 15. So go through and simplify a little bit. The square root of 18, well, it's not a perfect square root, but I can break it down a little bit. 30 is one of those weird ones. You would think that 30 would break down, and it does, 15 and 2, 5, 3 and 2, but there's nothing you can do with it, so we're actually going to leave it. We know square root of 9 is 3, so 3 times 2 is 6. Okay, we can simplify this just a little bit more. Square root of 9 is 3. Okay, so I'm going to end up with 6 root 2 plus 6 root 30 plus 6 root 15. Lots of 6's. But notice that the radicands are not the same, so you can't put them together. So that's actually the best you can do. Okay, last thing we're going to talk about. Okay, we're going to talk about something that's called a conjugate. A conjugate is a pretty simple idea. Okay, and the simplest way that I can describe it is if I have, let me just write it down here, if I have A plus B, then the conjugate is going to be A minus B. Or if I have A minus B, then the conjugate would be A plus B. Now, why do you care? Well, you care because you come up with a situation like this. Here you notice that we have a radical in the bottom. We got to get rid of it. Now, multiplying by like radical 5 isn't going to help us. Because if I multiply top and bottom by radical 5, you'll see that you'll end up still having a radical in the bottom. And so when you have a scenario like this, you're going to multiply by the conjugate of the denominator. So in this case, if it's root 5 minus 2, the conjugate is root 5 plus 2. Now that's helpful because let's go ahead and multiply the top. So if I distribute in, I get root 15 plus 2 root 3. And on the bottom, if I multiply root 5 times root 5, I get root 25, which is 5. Root 5 times 2 is 2 root 5. Negative 2 times root 5 is negative 2 root 5. And then negative 2 times 2 is negative 4. And if you multiply by the conjugate, what you'll notice is that these middle terms here always cancel out, which means your radical in the denominator gets eliminated. And so here you notice you go 5 minus 4 is 1, so all you're left with is root 15 plus 2 root 3. And that's it. But that idea of multiplying by the conjugate is important when you're talking about a denominator that has two terms, like 6 minus root 5, or up here root 5 minus 2. And it doesn't have to be minus. It could be 6 plus root 5. and then multiply by the conjugate. Okay, but the fact is, you do it when you have two different terms versus like up here, okay, where it had just one term. There's no plus or minus down there, so we were multiplying by these things. So let's try one more. So in this case, I'd multiply by the conjugate, so it'd be 6 plus root 5. 6 plus root 5, top and bottom. So when I do that, you got a lot of distributing here. So up on top, let's see. If I distribute the 1, I get 6 plus root 5. If I distribute the 2 root 5, you get plus 12 root 5 plus 2 root 5 times root 5 is 2 root 25. On the bottom, 6 times 6 is 36. 6 times 5 is 6 root 5. Negative root 5 times 6 is negative 6 root 5. Negative 5 times root 5 is not plus, it's minus root 25. So let's clean it up a little bit. I notice the square root of 25 is 5. So it looks like I can do 5 times 2 is 10, plus 6 is 16. And I have root 5 plus 12 root 5, so that'd be 13 root 5. On the bottom, these cancel out. And again, square root of 25 is 5, so I can just do 36 minus 5, which is 31. And there you go. No radical on the bottom, so mission accomplished. So that's a lot to do with radical expressions. Hopefully it all made sense.